This is question 26 from the GATE 2019 EC paper, in which we are given a differentiable function f of x such that f of minus 1 is 0 and the absolute value of the derivative is less than or equal to 2 on all r. We are asked to find out which of the following inequalities is necessarily true for x belongs to minus 2, 2. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic.
So in this question, we are given that f of minus 1 is 0, f is differentiable, and that f dash, the absolute value of f dash of x is less than or equal to 2. And we need to find which one of the following inequalities is necessarily true for x equal to minus 2 to 2. Right? So the approach here will be that since f of minus 1 is 0, what we'll try to do is to integrate f dash of x, right, between minus 1 and something, let's say b, and you will get f of x minus f of minus 1, and that will go away, right? So you will get some formula which has f of x. So we won't have f of x, we'll have f of b, right? But we will and of course we need all our all these inequalities are in terms of f of x. So what we will now need to do is to use some property of integrals which has an inequality in it, so that after taking the integral of f dash of x with that property, we will be able to we will have in our hand an inequality. So that will be the approach for this problem, right? So we are given that f dash of x is equal to the absolute value of f dash of x is less than or equal to 2, which means that f dash of x itself is between minus 2 and plus 2, right? So the property of integrals we will be using here is the rule of domination of integrals. That is, if you have some function, two functions of x, and you have one f of x and you have another, say, g of x, and at every point on the domain or between an interval of endpoints a and b, if it is such that g of x is greater than equal to f of x, you will find that, or well, in this case f of x is greater than g of x, you will find that the integral, that is the area under the curve, that is integral f of x, will also be greater than integral g of x, right? So if f of x is greater than g of x, the integrals will also follow suit. So how do we use that here? We already have an inequality in terms of f dash of x, and remember our goal was to be able to take the integral of f dash of x with some integral property. So let's do that here. So we can integrate on both sides, right, and the inequality will still hold. The idea is that even though our range is between minus 2 and 2, we'll split it, that is minus 2 and 2 can be written as minus 2 comma minus 1 union minus 1 comma 2. So in these two disjoint ranges, we will perform the integral and get the properties as necessary. All right. So let's perform the integral here. So we will take 1b belonging to minus 1 comma 2, and that will be used as the upper limit of our integration in the domination of integrals rule. So what we'll get here is that you will get minus 2 times x, and between b and minus 1, so that's b plus 1. Similarly here, right? So it's minus 2 times b plus 1 to b plus 1, and of course f of minus 1, f dash of x integral becomes f of x, and f of minus 1 is 0, so we're using that to our advantage. So now what we are left with is an inequality in terms of f of b, in terms of f of b. So dividing by 2, we will get this, right? And it can be compactly written as f of b is the absolute value of f of b is less than or equal to 2 into b plus 1. Remember, this is for b belongs to minus 1 comma 2. Next, we will take the second range, which is okay, yeah. So basically we will get that for b belongs to minus 1 comma 2, b plus 1, right? B plus 1 will be 0 comma 3, so that's purely non-negative, and so we can take that b plus 1 is equal to mod of b plus 1 and replace b plus 1 by mod of b plus 1. So this is the inequality number 1, right? Secondly, we can, so now we take the second second interval, which is minus 2 comma minus 1, and again we take a b belonging to this interval as the lower limit of the integration. So it's in the rule of domination of integrals, this is the lower limit of integration, and again with the same inequality that f dash of x is between minus 2 and 2, we integrate on both sides and we obtain, after a lot of reduction, this expression, this inequality, right? But this is greater than or equal to 0. Why? Because b plus 1 will then belong to minus 1 comma 0, and so therefore minus b plus 1 will belong to 0 comma 1, right? So this is greater than or equal to 0. So that means the absolute value of f of b by 2 is less than or equal to minus b plus 1. So that is the limit over here, and so you can take that f of b is less than or equal to minus 2 times b plus 1. Absolute value of f of b is less than or equal to minus 2 times b plus 1. Finally, we can replace minus b plus 1 by mod of b plus 1, because remember we just said that it was greater than 0, and we will get that absolute value of f of b is less than or equal to 2 times mod of b plus 1, right? So for the entire region, right, so we've gotten the same inequality over here, right, in 2 regions. So same inequality, we've gotten it in 2 regions, which means it is true for the union of those regions, which is the interval in question, right? So, and finally what's left to remark is that f of b will always be less than or equal to absolute value of f of b. So the you can replace absolute value of f of b by something smaller, which is f of b, and so this corresponds to the answer B in our question, right? So B is the answer.